Okay, our topic today is volumes of pyramids and cones. Now, you've probably got this already, but when we're talking about volume, we're talking about the stuff that is in a three-dimensional figure. So, for example, if we were talking about a cone, we'd be talking about how much ice cream would actually fit in there, as opposed to how much it would take of the waffle stuff to actually make the cone, which would be more like surface area. Okay? Now, when we're talking about volume, it's a little bit complicated to understand. So I want to start with this idea. Let's say that I had a cube, so all the sides are the same, and inside that cube I were to draw a rectangular prism. It would look something like this. Again, as you know, I'm not much of an artist, but let's say that I drew myself a rectangular prism that looked like this. Okay, hopefully you can see that in a three-dimensional sense. And then inside that rectangular prism, I'm going to draw a pyramid. My apologies, but my red marker is not very good. Anyway, so I have the cube. Now, if you knew the volume of the cube, that would be the base times the length times the height, the breadth times the length times the height, or whatever that is, cubed. Okay? Now, if you think about this triangular prism that's inside it, what's the size of that in relation to the cube? Well, if you think about it, if we were to cut that right there, it would be half of that, and it would be half of that. So overall, it would be half the size of the cube. Now, ignore the cube for just a second and think about just the triangular prism, and then think about the pyramid that's inside that triangular prism. Well, it's not half, it's quite a bit more than half of the triangular prism, but clearly it's smaller than the whole thing. Now, we could go about and figure that out. It's a fairly complex mathematical tool. If you ever take calculus, you may talk about exactly how this is derived, but let's just make it simple and say that the volume of a pyramid, volume of a pyramid, or of a cone, because the same applies to a cone, the volume is equal to 1/3 of the area of the base. It's a capital A because it's the area of the base times the height. So, for example, if we were to get rid of my rather complicated drawing here, and actually draw ourselves just a regular pyramid. And let's say that we had a pyramid that was 1.2 along this side, 1.4 along this side, and the height of our pyramid was 1.3. Clearly not drawn to scale. Then what would I need to do? I would need the area of my base. How would I get the area of the base? 1.2 times 1.4. You can probably do that in your head, but let's just do it here. 1.4 times 1.2 gives me 8. 14 is 1.68. And then I multiply that times the height. I multiply that times 1. That gives me the area of the base multiplied by the height. So I get 405.168, 4812. But I don't want all of that, I only want 1/3 of that. So I'm going to divide it by 3, and I get 0.728. 0.728 units cubed. Let's say they were centimeters, and that would give me centimeters cubed. Okay? The area of the 1/3 of the area of the base times the height. 1/3 area of the base times the height. Similarly, if I have a cone, it's still 1/3 of the area of the base times the height. So let's say that I had a cone that was 29 millimeters high and 29 millimeters across, 22 millimeters all the way across. Now we already know the area of the formula for the area of the base of the cone, because it's a circle. What's the area of a circle? Well, it's pi r squared. So we can take this formula, we can say volume equals 1/3 A times h, and we know that the area of the cone is pi r squared, so we get 1/3 pi r squared h. We just replace the a with pi r squared. What's the radius of the cone that I've drawn? It's not 22, that's the diameter. The radius is only half, it's from the center outward, so that means that I have the volume is equal to 1/3 times pi. The radius is 11 times h, which is 29. And we could leave that, we could multiply 29 times 11, which gives us 319. And so we could leave the volume as 319 over 3 pi. I'd be simplifying it. If we wanted the exact answer, that's how we would do it. Or we can pull out our handy dandy calculator and we can put this in and we get 319 over 3 times pi. And if we wanted to go to 2 decimal places, we would get 334.06. And we're in millimeters, so we have millimeters cubed, and we're done. Now you notice there's another figure here. What is the difference in this figure? This is a right prism, a right cone, which means that the vertex is directly over the center of the base. This one is called what? This is called not a right cone, but an oblique cone. O-B-L-I-Q-U-E, an oblique cone, which means that the vertex is not directly over the radius, it's off-center to some degree, but the formula is still the same. Volume is equal to 1/3 the area of the base times the height. And again, you'll notice the base is a circle, so that's still the area here, and the height is this distance, the distance from the vertex straight down at a right angle to the base. We could also have, by the way, oblique prisms. It would look the same, except that the vertex would be over to one side. Formula works exactly the same. And that is volume of pyramids and cones.